So this is lecture number 40. Today's date is 28/10/2020. I'm going to continue with the topic kinetics of particles. Yeah. So it's a simple problem that we will begin with today's class. Look at that. I'm going to draw a diagram that represents a small passenger car. It is on a slope, gentle slope of 10 degrees, but I have exaggerated the slope here. This is 10 degrees. So I have a small car. Which weighs 3,500 Newton. That's why it's a small car. And this car is moving down this gentle slope of 10 degrees, right? And the instant that you look at, the speed of this is 20 meters per second. So how many, what is the kilometers per hour? It is into 3.6. So you have 72 kilometers per hour speed. This vehicle comes on this road of gentle slope of 10 degrees. Suddenly there is a disturbance that is visualized, which is seen by a driver of this vehicle, and he jams on the brake and causing all these wheels, 4 wheels, to lock simultaneously. So the braking system is employed with the ABS, so that locking would cause simultaneous locking. So he jams on it, it is locked, and this vehicle skid in a straight line. It is skid in a straight line. That means this complete vehicle is assumed to be a vehicle which is of block, right? So the locking, it is not employed with the modern controls ABS system where it is not locking simultaneously at a time. It will release and lock. That's a safety purpose. It is there. But this is a old car that he drives, and he jams on the brake. What is happening? All the wheels of both axle are locked, and then it is as good as sliding of block on this slope. So you have the surface contact as given by mu k, which is 0.5. All right. So now what is the question is, determine how far and what time that the vehicle takes to stop on this slope. That's the question, right? So that is the question. So the instant shown here, it is 20 meters per second speed. If the driver jams on the brake, all wheels locks and vehicle skid on a straight line. This is the condition given. If that is so, if that is so, what distance, what is the stopping distance? What is the stopping distance? And what time does it take to stop? That's the question. So how do you solve this? So this can be solved by drawing your free body diagram and its effect diagram. So this is your weight, and I will have, since all vehicles are locked, the geometry of this car is not considered. So I will have here its weight normal, and this will be going against the kinetic friction force, that is 0.5 times N, and there is no other force, right? So this is that. So this weight can be resolved into two components. And if this is 10 degree, this angle is 10 degree. So this horizontal component is 3,500 sine 10 degrees, and this vertical component is 3500 cos 10 degrees. So now what is happening when brakes are applied, the velocity, the speed here is 20 meters per second, will reduce in next instant, it is going to stop. So the motion is decelerated motion. So what is the rate of deceleration is what you have to find out now. So for that, let me apply Newton's law. So this is what is the free body diagram at that state. And now what is that effect force, the braking force? That is mass times acceleration, or I can also represent that as a D'Alembert's force. So D'Alembert's force will be what? Deceleration, it is decelerating. So D'Alembert's force will be in this direction. What is the direction it will act? Or if that is confusing for you, what do you have to do? Take the same diagram. It's always better to apply Newton's law around. This vehicle. So this is what is the braking force, M times A. So if this is braking force here, on the other side it would be inertia force that is in the same direction. So this is what is because of this free body diagram is what is this side sigma F A, sigma F, and this side it is MA, right? So you can now find out what is this deceleration rate. Just let us work out, write the equation along a vertical direction, find your, 1 minute. So if I apply sigma fx, so along this line, if this is positive, if I consider convention, if I apply this equation sigma fx equal to MA, so sigma fx here is what? Say this force is down, so it is minus 3500 sine 10, and this force is up, so plus 0.5 n. So what is n is if I have my this vertical equilibrium, that is sigma fi equal to 0, so this is sigma fx equal to ma. So sigma fi equal to 0 when I apply, so that's going to be n is 3500 cos 10, that's known. So this is on one side, and that will be equal to MA on the other side. So that is 3500 divided by 9.81 into A on the other side. Right? So now I can find out what is this A. So that's going to be 0.5 into 3500 cos 10 minus 3500 sin 10 divided by 3500 by 9.81. So what is the answer that you get? So it's cos 10 minus sin 10. So I'll have here this value equals to, I have 3.13 meter per second square. So this is the deceleration rate. So this A here, this direction here itself is deceleration rate. So it is slowing down in the negative direction. So it is the deceleration now, right? It is coming down. So you have got this A now 3.13 meter per second square, which refers to this. So is that correct? Say cos 10 minus sin 10. So I think this minus sign will get. So minus sign refer here, it's a deceleration rate. So now by kinematics, I can find out what is the distance, stopping distance, because you could relate that with this secondary motion equation. V squared is equal to V naught squared plus 2a x minus x naught, right, in this formula. So here what is V naught square is your 20 meters per second. So 20 square minus 2 into 3.13, and x minus x naught is what is stopping distance x. If I consider x naught as 0, from that point, if I consider that is x, and here final velocity is 0, so I will be able to get what is my x as 400 divided by 2 into 3.13, and I will have the value equals to 63.9 meters. So that's what is the stopping distance. And what time, what is the time taken to stop? That would be easy again. I'll use one of the motion equation, primary motion equation, that is V is equal to V naught plus AT. So this is 0 and this is 20 and this is minus 3.13 T. So T will be 20 by 3.13. You will have the value 6.396 seconds. It takes this much of seconds. So this is that straightforward to solve. So kinematics we have done first in hand is because you'll have to solve the problems where you are not knowing any of the motion parameter. You are given data like that. You require at least one motion parameter, and readily available motion parameter from the fundamental equation of motion, governing equation, is acceleration, and that we get applying Newton's second law. So here when I apply that, I get my deceleration rate, and I use that in my kinematic equation, which I have already studied for a rectilinear motion. And since it is going to be constant, see, why do I take this as a constant? You look at here, this 3,500 is weight, 3,500 is weight, 3,500. So this goes off. So 9.81 is constant. 10-degree slope is constant for the road. So whatever this d you get is constant rate. It's constant. So since the acceleration is constant, I could apply these equations. So this is, there are three equation of kinematic equation for uniformly accelerated or decelerated motion. So I use appropriate equation. So first I use the secondary motion equation to find the distance travel, stopping distance, and I use this primary motion equation to find the time. So that's very simple. Or I can also use to find time, use this S and then the other equation. What is that? X is equal to V naught T plus half A T square. I can also use this. So this X I can substitute. V naught is 20 times T minus. So it's a quadratic equation of T. When I solve for the T, I will get this value 1 positive. And I have to take this value as my time required to stop the vehicle. So I can use this, but instead of using this is readily available independently. I can do. I don't require this to calculate this. I don't require time to get this. So one can complete this problem. So this is a simple problem I have taken. Why did I take this problem is because I'm going to solve the same problem by other means. That's what is the other form of Newton's law. So what is that? You know what is